5, 4, 3, 2, 1, 0.
Hi madam and my fellow friends, I'm Priyanka here. So today we would like to present about infinite impulse response, which is FIR filter. So here is my group members: Amila Rashid bin Rizwan, Dada Nafal bin Muhammad Razi, Priyatarshini Ramalingam, and also myself, Priyanka Sukalingam. My part I would like to present, which is about abstract. The performance of the system is significantly impacted by interference in the input signal of digital processing. To obtain a meaningful signal, the input signal must therefore be processed. In the processing of digital signals, the infinite impulse response, which is FIR filter, is critical. The performance can be also enhanced, and the complex computation in the simulation can be made simpler by using MATLAB to design the FIR filter. The design of the FIR filter has been handled by MATLAB using the window function, frequency sampling, and convex optimization approaches. We may obtain the amplitude frequency characterization in the context of MATLAB application that was created for it. The filtering impact of various digital filters is compared by comparing the signal generated amplitude frequency diagram using the FIR digital filter that were created the process of input signal based on MATLAB function. The experimental findings demonstrate the viability of the FIR filters proposed on this study. That's all. Thank you.
Next is introduction. What is FIR filter? One of the most fundamental components of a digital signal processing system is the finite impulse response FIR filter, which can ensure a strict linear phase frequency characteristic with any amplitude frequency characteristic. FIR filters are a stable system because, in addition, the unit impulse response is finite. The FIR filter has a wide range of application in numerous industries, including telecommunication, image processing, and other areas. Next is, there are several filter types including low-pass filter, high-pass filter, band-pass filter, and band-stop filter. A low-pass filter is used to filter out high frequency since it only allows low-frequency signal to pass through its output. Controlling the highest range of the frequency in an audio signal is easy with a low-pass filter. The high-pass filter finest demonstration is its ability to eliminate the 60 Hz audible AC power, which is the USA may be picked up as background noise for nearly any communication.
Alright, as you can see right here, for the previous lab, we using the low pass filter, and also we have two spectral analysis. The filter that we use is low pass filter, which is the IIR Butterworth, and for the frequency we put 48,000, and then for the FC we put 10,800. So we set the filter to the low pass filter, and then as the result we get the frequency like this. Oh, it is switch. I turn it on for the without the filter first. So as you can see right here, this is the result for without using a filter. And now after we change it to the filter, and the background of the pitching noise will be removed, and we can only hear the voice only. And now I start running. Now, as you can see, with the filter, we can hear clearly the voice of the people recording. And now, next, for the new project that we done is that we're using a low pass filter. Instead, we're using IIR. We're using a FIR instead. So as you can see right here, we use IIR, but in low pass. And also the frequency that we use is we change the frequency. So to show the different the filter of low pass filter, the filter of IIR. So this is the frequency, which is 22,050 that we put, and then the second frequency that we put is 7,350. Now we start the and also we put time scope for the filter and for without the filter, so we know the detail for the wave of frequency that it show for the noise. And then I put the switch for the filter first. So this is the result for the without the filter for the time scope, and for the blue one is the filter for the time scope. And then as you can see right here, the result is we saw it clearly when we using a filter, and for this one is without a filter. And now we move on to the next new project, which is we using a band pass filter. Band stop. We also use IIR Butterworth, and for the frequency they have two FC, which is FC1 and FC2. So the FS we use the same value, which is 22,050, and then for the FC1 we got 7,350, and for the FC2 11,025. And now like for the previous our project, we also use a time scope for the band stop filter to see clearly the result for the waveform. Oh, and also the switch that I use is for the without the filter first. So as you can see right here, the difference between the time scope. For this one, we see the without the filter, which is there is more noise, and then for the second time scope, that we see the clearly for the actual wave, the actual noise that we see without without the pitching noise, and then as you can see right here, we got the result. This is for the without the filter, and then for this one is also with a filter.
Okay, so for the conclusion, we learn about the type of each filter and understand their characteristics. We also learn the definition of a FIR filter and study the usage and benefit of it in the modern world. So finite impulse response, FIR filter, is a filter whose impulse response is of finite duration because it settles to 0 in finite time. FIR filters can be discrete time or continuous time and digital or analog. Finite impulse response (FIR) filter are widely used in communication such as consumer electronics, audio and other signal processing applications. Thank you.